The bar of being a backend developer is higher than it ever was. It's not enough to just know your framework or to just know your language anymore. Now you need to know how to write a code, how to write a software in a way that it would survive in a complex, distributed world. Languages and frameworks are indeed important, but in this roadmap I will show you things that are more fundamental and that will make you a better backend developer independently on your language and framework of choice. Hi, my name is Pasha Finkelstein. I'm a developer advocate for Bellsoft and I've been a software architect for more than 15 years. And this video is what I've learned in the fundamentals during these 15 years. What you see on your screens right now is a huge mind map of the topics I consider important for backend developers to learn in 2026. It consists of 3 parts: data, security, and architecture and communications. Notice I don't put anything code related here, like debugging or profiling. These skills are essential for any kind of developers. I also do not put anything AI related here, because we all work with AI, but we need to know where should we look at. And this mind map will help you to become better backend developer independently of your usage AI in your development workflow. By the way, the video is quite fast, so if you need to come back to this roadmap a little bit later, then the link to the PDF with this roadmap is down below in the description. The first thing crucial for backend development is storage, is databases. And obviously, most of us will work only with relational databases most part of their careers. So, what is the most popular database these days? It's PostgreSQL. If you already use it, if your company uses it, you should probably look at its documentation. Documentation is brilliant, it has a lot of examples, it has a lot of information you didn't even think of. It's big, but probably you can spread reading it over the course of the year, for example. It will be fine. You also can skip obviously irrelevant things to you. For example, usually you don't need to know how to deploy it. That's fine, other people will take care of it. Probably it's not your job. And since we are talking about relational databases, you obviously should be proficient in SQL. Probably this is the hardest part in this whole roadmap, because SQL can be complicated, it might be hard to learn. Even though it's a declarative language, it has a lot of things like window functions, common table expressions, recursive common table expressions, analytical functions, many available aggregations, many data types, and so on. At least you should know where to look for them. And you should remember what CTE, common table expression, is and where to look its syntax, so at the time when you need it, you could use it. Also, a lot of developers know about third normal form of databases and they think that it's a perfect form. But no, there are actually 7 normal forms of database normalization, and you should probably be familiar with all of them because you should choose one depending on your particular situation. Now, you should also know at least a little bit about the theory of distributed systems, which is partially about data and partially about communication. And I'm talking about first CAP theorem. You should know what is consistency, availability, and partition tolerance. You should know where your system in this CAP theorem is, and you should know where other systems in your company are in this theorem, so you would be able to argue about availability, consistency, durability of your system in the whole. Also, there are a couple of useful initiations. One of them is called ACID, and the second of them is called BASE. Got it? ACID and BASE. ACID stands for atomicity, consistency, isolation, and durability, while BASE stands for basic availability, soft state, eventual consistency. You can meet both kinds of systems in the wild, And you need to know what system is what to be able to talk about guarantees of the system in a whole. But of course, we shouldn't forget about other kinds of storages too. Key value storages, document storages, vector storages, graph storages. They are created to solve particular narrow tasks, but sometimes they are the best solution for your particular tasks. So please read about them to be able to make conscious decision about what you want to use in this particular situation. We usually will use key value storages for cache and vector storages to work with AI systems. Now let's switch to the next large branch of our mind map: architecture and communication, and obviously let's start with architecture. There are three essential things you should know about architecture. You should know what microservices are and how to build systems with them, how to build a proper modular monolith, and how to use serverless things like Amazon Lambda, for example. But of course, there are other architectural patterns too, for example, CQRS. They're not as popular usually. You won't see we need to build CQRS system in a job description often, but still it's better to learn them. I don't put them into this mind map because I don't consider this knowledge essential. Still better for you to know it. Now let's talk about communications. I want to split all the communication protocols into several families: synchronous, asynchronous, and streaming. Synchronous protocols are, for example, REST, if you call it a protocol, or HTTP, GraphQL, which also runs over HTTP, and gRPC, which also runs on top of HTTP. What is interesting, gRPC stands somewhere in between synchronous, asynchronous, and streaming protocols, because internally it doesn't have a block, but for you, since it's a remote procedure call language, it looks synchronous. I divide asynchronous protocols here also into subfamilies: message queues and event streams. And message queues are, for example, RabbitMQ or ActiveMQ, while event streams are something like Apache Kafka and Apache Pulsar. You don't need to know all of them in depth, but you need to understand the basics. You need to understand what's the difference between queue and topic to make conscious decisions in your design and architecture. And the separate thing you need to know is WebSockets. WebSockets are essential for backend developers for two reasons. First, they might be a nice asynchronous protocol to communicate between two backend microservices. But on the other hand, it can be a nice protocol to communicate with frontend, and usually there is some kind of backend behind frontend. You should know what WebSocket is, you should know what Keep Alive is, and so on. Independently on which framework you use and your application, it will make you a better developer. And the last thing I want you to learn about is system design concepts. They start from the OSI model, which tells us about different protocols and how they work. And also, you obviously need to know about load balancing. And by the way, load balancing can happen on level 4 or level 7, which reference you to the OSI model. Of course, you need to know about rate limiting and throttling for your APIs and for your software in general, and about circuit breakers. And now let's talk about Forest backend. I lied 5 minutes ago when I told you that it's about security. Not only, security is just a very important part of backend. So let's talk about it first. First, you should know what is OWASP Top 10. Top 10 most popular vulnerabilities in backend services all over the world. Second, you should know about authentication versus authorization. What is the difference? Authentication is called Auth-N here, and example of it are OpenID Connect, Magic Links, bio-authentication, passkeys, username, password authentication, all of them. While authorization can be of two types, and it's about access to resources, role-based or attribute-based authorization. Both of them exist, and you should know what is better for each system to be able to make a conscious decision about your design. You should also know about encryption, what's in transit and what's at rest. Of course, for modern APIs, you should know about rate limiting and throttling. Now, to build a reliable fortress, we also need to know the building blocks of it, and obviously it's about infrastructure as a code. First, there are tools to deploy our software and define our landscape like Terraform and Pulumi. Second, of course, we package our software in containers, so we should know about Docker and containers. And of course, we need to know about Kubernetes because it's being used almost everywhere in bigger companies these days. We need to know orchestration, we need to know secrets, we need to know all the basic primitives of Kubernetes. Again, we shouldn't be Kubernetes administrators, but we should understand how the things work. And lastly, continuing the metaphor of fortress, we should be able to look at our fortress and see cracks in there. For that, we need to know our observability stack. We need to know OpenTelemetry, which is the de facto standard of telemetry these days. We should know about Grafana dashboards, we should know about metrics, and we should know about alerting and monitoring. Now, to address several points. First, I know that it's a lot to learn, but again, you don't need to learn everything in depth. You need to know where to look for it in the first place. Of course, there are essential things, like you should know what message queue is, for example. You should know about authorization versus authentication. But you don't need to know all the particular implementation details. Second, I know that it was fast-paced. There will be another video soon about the application of this roadmap to Java, but you always have this PDF down in the description for your disposal. Third, if you like this video, like the video, leave a comment. I'm happy to answer, and hopefully see you next time. Bye bye.